Welcome to my class of operating system. Today we will learn about protection. What is protection and what are the goals of protection? The process in an operating system must be protected from one another's activity. To provide such protection, we can use various mechanisms to ensure that only processes that have gained proper authorization from the operating system can operate on the files, memory segment, CPU, and other resources of a system. Protection refers to a mechanism of controlling the access of program, processes, or users to the resources defined by a computer system. This mechanism must provide a means for specifying the controls to be imposed together with a means of enforcement. We distinguish between protection and security, which is a measure of confidence that the integrity of a system and its data will be preserved. Protection refers to a mechanism for controlling the access of program, processes, or users to the resource defined by an access restriction by a system. We can take protection as a helper to multi-programming operating system so that many users might safely share a common logical namespace such as directory or files. Protection ensures that the resource of computers are used in a proper way. It ensures that each object accessed correctly and only by those processes that are allowed to do so. OS designer faces challenge of creating a protection scheme that cannot be passed by any software that may be created in the future. What is the need of protection? To prevent the access of unauthorized user, to ensure that each active program or processes in the internet site, to improve reliability by detecting latent error. What is the goal of protection? We need to provide protection for several measures. The most obvious is the need to prevent the bad intentional violation of an access restriction by user. An unprotected resource cannot defend against misuse by an unauthorized user. A protection-oriented system provides means to distinguish between authorized and unauthorized usage. Obviously, protection is done to prevent malicious misuse of system by users, to ensure that each shared resources is used only in accordance with system policies, which may be set either by system designer or by system administrator, to ensure that errant program cause the minimal amount of damage possible. It is kept in mind that protection system only provide the mechanism for enforcing policies and ensuring reliable system. It is up to administrators and users to implement these mechanisms effectively. The role of protection in a computer system is to provide a mechanism for protection, mechanism for implementation of policies governing resource use. These policies can be established in a variety of ways. Some are fixed in the design of the system, while others are formulated by the management of a system. Still, others are defined by the individual users to protect their own file and program. A protection system must have the flexibility to enforce a variety of policies. What is the principle of protection? The time-tested guiding principle for protection is the principle of least privilege. It dictates the program, users, and even systems be given just enough privileges to perform their task. The principle of least privilege can help produce a more secure computing environment. This ensures that failure do the least amount of harm and allow the least of harm to be done. For example, if a program needs special privileges to perform a task, it is better to make it a SGID program with group ownership of network or backup or some other pseudo groups. The root account should not be used. We need that root privilege. The root account should not be used for normal day-to-day activities. The system administrator should also have an ordinary account and reserve use of root account for only those tasks which need the root privileges. Access control. With this we come to access control. Access control is concerned with determining the allowed activities of valid user, mediating every attempt by user to access a resource in the system. Basic terminologies are object, an entity that contains or receives information. Access to an object potentially implies access to information it contains. Example, file, program, printer, disk, etc. Access right, the permission granted to a user to perform an operation is called access right. Example, read, write, execute, etc. In this diagram, source, that is user processes which are termed as subject, places access request, and the guard then considers the access control policy, and after consulting access control policy, object is allocated, that is resource is allocated. Files, printers are known as different resources. Domain is collection of object and a set of access right for each of the object. A process operates within a protection domain that specifies the resources that the process may access. Each domain defines a set of objects and the type of operations that may be involved on each object. The ability to execute an operation on an object is an access right. System will consist of such multiple domain, each having certain predefined access right on different objects. Domain execution of process, it can change the domain, that we call domain switching. A domain can be realized in a variety of tables. Each user may be a domain. In this case, the set of objects that can be accessed depends on the identity of a user. Each process may be a domain. In this case, the set of objects that can be accessed depend on the entity of the process. Example of Unix. In Unix operating system, a domain is associated with the user. In Unix operating system, each user's ID is used for identifying the domain. Now, access control matrix or access matrix. Our model of protection can be viewed abstractly as a matrix which is called access matrix. The rows of the access matrix represent domain and the columns represent object. Each entry in the matrix consists of a set of access right because the column defines object explicitly. We can omit the object name from the access right. The entry access ij defines the set of operations that a process execute. In domain D1, we can invoke object oj. To illustrate this concept, we look into the following diagram. There are 4 domains: D1, D2, D3, D4. 3 files: F1, F2, F3 and 1 ledger printer. A process executing in domain D1 can read files F1 and F3. A process executing in domain D4 has the same privileges as one executing in domain D1, but in addition it can also write onto files F1 and F3. The ledger printer can be accessed only by a process executing in domain D2. The access matrix scheme provides us with the mechanism for specifying a variety of policies. The mechanism consists of implementing the access matrix and ensuring that the semantic properties we have outlined hold. Most specifically, we must ensure that a process executing in domain D1 can access only those objects specified in the row I, and then only as allowed by access matrix inquiries. The access matrix can implement policy decisions concerning protection. The policy decision involve which right should be included in the I or J entry. We must also decide the domain in which each user process execute, the last policy is usually decided by the operating system. Now, if a process domain D tries to do operation on object D1, then operation must be in access matrix. The access matrix provides an appropriate mechanism for defining and implementing strict control for both the static and dynamic association between process and domains. Uses of access matrix designs separate mechanism from policy mechanism. Operating system provide access matrix plus rules. It ensures that the matrix is only manipulated by authorized agent and that rules are strictly enforced. Policy, user dictates policy, who can access what object and in what mode. Thank you for watching.